Hello friends, welcome to my YouTube channel. So this is going to be my first tutorial for the YouTube channel. So today we are going to start with OpenCV. So in Python we are having three libraries for image preprocessing. Firstly we have PILO, secondly we have skimage, and thirdly we are having OpenCV. OpenCV stands for Open Source Computer Vision Library. So today we are going to start with OpenCV tutorials. So in this tutorial what we're gonna do is we'll try to load the image and we'll try to smoothen the image by using some filter, and after that we'll try to extract some information by using the canny detector, and after that we are going to use the threshold function and we'll try to draw the sketches of the image. First of all we'll try to do on the image itself, and then we'll try to do on video by using our webcam, or if you are having any external camera. So let's get started. So first of all we'll import the required libraries. So first we'll import numpy as alias np. Then I want to show some plots of histograms. If you are a photographer, then you know what histogram looks like. If you are not, then don't worry, we are going to cover in this tutorial. Just stay tuned. Okay, so we'll use matplotlib pyplot as alias plt. After that we require OpenCV library itself, cv2. So first of all we need to load the image. So I'll make a variable called img. So we'll use the imRead function to read the image. Here we have to give the name of the image, or we have to give the path of the image. I'm having the image in the same directory of my notebook, so I don't need to give the whole path. So I'll call my image. If I run the cell, nothing happens. Why? Because I have just load the image. We are just reading the image. If we want to see the type of the image, we can use the built-in function type of image. So it says it's class numpy and array, which means it is a numpy array. It is a series of numpy arrays. That's why I have imported the numpy library. If we want to do any manipulation with the image, if we want to play with the pixels of the image, then we can use this numpy library. It is really powerful library. After that we can check out the shape of the image also. So to do that, let's call the shape function. So it is 800 by 800 by 3. What it means? So 800 width, 800 height, and 3 channel. So basically this is a colored image, that's why it's written 3 here. So if I want to show, oops, sorry, for example, this is our image and these are the pixel locations. These are the pixel locations. So here my 800 height, this is my 800 width, and this one is for my depth. So this is my depth, which is 3, meaning this one is red, second one is green, and third one is blue. So this is a 3 channel image. If I want to convert this into black and white image, if I want to convert it into black and white image will be same, but now it will have only one depth because I have converted into black and white. So nothing will happen to width or height, it will remain same. But if you see this depth, here it is 3, but here it will remain 1. Why? Because I'm converting into black and white. So let's convert this one. We can do here also. This is not a good way, but since Python is giving us opportunity to convert by just loading the image. So now if we see here, right now I don't have any depth, which means I have converted this image into black and white. To show the image, first of all let me comment out this print function because we don't need this one. So let's load the image. I mean, let's read. After reading the image, let's see the image. So by using cv2.imshow, we can show the function. It takes 2 arguments. In the first argument we have to give the name of the window. So I'll give the name original image and the image itself. If I run the cell right now, it's gonna freeze my computer. I don't know the reason, but it is going to be freeze. So if you wanna try, just go ahead. Usually when we say no, don't do this, people first of all do that. So all the very best for that one. And to show the image, we have to use the wait key function. So it is going to wait for some time, and after that we want to destroy all Windows. Don't worry, if you are using the Windows, Mac, Linux, any system, it is not going to crash your Windows. So why are we writing this set of instruction? So when we want to show the image, a separate window will pop up, and with using this wait key function, we are deciding how much delay we want to give. If I press shift tab, so here you see it takes one argument delay, how much time we want to freeze that window, I mean we want to pause that window. And if we press any key, we want to destroy all the windows, so that popping out window of that image, we want to close it. So let's run this one. Oh, let's remove this one. So this is our image. It is image of neuron. I think doctor knows about this one, dendrites, then neurons and perceptron and blah blah. So if I press any key, it will close out. Now if I give a time delay of 1 millisecond, so see, after 1 second it will automatically closing, because we are using this destroy all windows. If I put 2000 here, it will just wait for 2 seconds and it will close automatically. You see, let's not do it right now. So first of all, what we want to do, we want to convert this image into grayscale. For that, let's convert it. So if you are newbies, don't worry, you don't have to remember all the functions. As much as practice you do, as many as tutorial you watch, you eventually gonna remember it. So CVT color. So here, if you are using Jupyter Notebook, if you press shift tab, so here it gives the help. If you want help like what this function is doing, so here you can see all the instruction. So first of all, we have to pass the image, and then we have to convert it into grayscale. So I'll write down PGR2, and if you press tab button, then it will give you a separate options like what you want to do with this one. So let's go with BGR to gray, and we'll write down, okay, let's just copy paste. Someone invented copy paste, so let's just use their effort. So this is our grayscale image, write down gray. So now this is our black and white image, the grayscale image. After that, if I load the image again, you see here these are some noise. If you know about photography, you know very well, like here like there are lots of noise, you cannot see the picture very clear. So for that we require filter. So for that we have 4 5 type of filters. So first one is average filter. So what it does is, let me clear out this one. For example, this is your image, okay? So this is your image, and we want to filter. We will use size 3 by 3 filter here. So what we'll do is, we are using the average filter. So here all the pixel values will be written in the boxes. For example, 8, 7, 55, 33, 98, 78, 5, here again 0, 7. And before doing that, I want to clear one concept. 0 means it is a black, and oops, 255 means it is a white. So our image value, the pixel value between 0 to 225. 225, sorry, it's 255. So here we have all the values, and I'll quickly write down some values. 17, oh, I changed the color, it's okay. Now here 8, and again here let's write down 1. So this is my average filter. and since we are taking the average, we'll write down this one. So it will go. So this is my 3 by 3 filter. So when I apply this filter onto this image, it will sit here on 3 by 3. Now everything will be multiply here, and it will, or everything will be divided by 9. So 8 by 9, 7 by 9, 17 by 9, 7 by 9, 5, 55 by 9, 8 by 9, and after that it will go here, and likewise it will go like this. Then after that it will go here, sorry, here, and likewise it will go, and it will just smoothen the image. So this is the average filter. Then we have a Gaussian blur. So Gaussian blur came from the Gauss's bell curve. Oops. No, this is not good. So this is Gauss's bell shaped curve. So in this one, the values will be 0 here. Here let's take 4. Here let's take 1. So this is basically nothing but a Gaussian blur image. So it will just try to smoothen the image, and after that we have a median filter also. What it will do is it will find out the median value of the particular image pixels, and it will put the median value, and median filter is a nonlinear filter. So just before applying, just try to know the application of this one, but we are right now we are just learning. So let's call all the filters. So first of all, we'll start with Gaussian filter. So we'll call CV2 Gaussian blur, and it takes 3 values. So first of all, we'll take grayscale. Then we have to give the kernel size. Here I'll give the kernel size 5 by 5. Then the third argument is called sigma. If we check the doc string, it says sigma. So right now we are just learning, so I don't want to go in depth, but if you would like to know what is this value, why are we using 5 by 5 kernel, what if I use 3 by 3 kernel, or what if I use 11 by 11 kernel, just put your request in the comment box, and I'll make a separate video particular on these values. And if you want to see the blur image, again let's just copy paste this command. So Gaussian image, Gaussian, let's run this one. Let's close this one. Oh, let me first of all apply on our image. Yeah. So you see here, this is my Gaussian. So you see here I'm having a lot of noise, but here it is smoothing some noise. So here I'm having less noise, but it is affecting our original image. So to avoid this one, basically we cannot avoid this one, but what we can do is, first of all, let's convert this into gray, and let's quickly check out the median filter. So cv2 dot median blur. So here we'll convert the grayscale. If you see here, we have to just write down the kernel size, so it will automatically take 5 by 5, and let's median blur. So let's run this one. So this is our Gaussian, this is my grayscale, I don't need this one. So this is my median. So if you see here, you see, if I put side by side, here I'm having some, here I'm getting rid of some of the noise. You see here it is smoothing this one a little bit better. So after this one, let's try to find out the edges of the image. So for that, we have a canny edge detector. We have Sobel, x direction, Sobel y direction, but canny is all about canny also contains Sobel. So let's just go with canny as of now. So let's call cv2 canny. Let us pass the Gaussian image, and we'll give Now we have to give the threshold value, threshold 1, threshold 2. So let's go with the 3-time ratio, 50 to 150. So what it will do is any pixel intensity below 50 will be extracted. Any pixel intensity between 50 to 150 or 150 to above, that we're gonna see here. So let me comment out this one. We don't want gray also, we don't want this one also, and here age image, and here I can call my canny function. Oh, it's not responding. I think I haven't run this cell, so just quickly run this cell. Yeah, you see here now, much better. Now I can see the edges of this image. You see how it is very clean and nice, and by playing with the pixel intensity values we can actually extract the information. You see now I took too much high pixel intensity value, that's why I'm losing some some information. So it is between 50, so I think this is much better. 50 to 150. Again I can go a little bit down also, 10 to 50. Yeah, but now I'm not having all the edges, it is containing some noise. So let's me take just 150 to 100. And how to choose these values, if you want to know that also, just put request in the comment box and I'll try to make a separate video on that one. Okay, so after seeing this scheme, now we can move forward to, I think I need to rerun the cell. So you see this is my canny edge detection image and this is my original image. So now we can move to next step, which is to get the threshold of an image. So for that we'll use threshold function, and if you press shift tab it requires four, it takes 4 arguments. So first one is the picture itself, so let's take canny. After that we have to give the threshold value, so it's 50 and maximum value is 255, and then we have to pass the argument for what type of mask we want to get. So for that we will apply binary inversion and we will see mask. Okay, so that is the sketch image, like the sketch artist image of the neuron. And if we want to follow this in video camera, then what we can do is basically we can make a function. So first of all let's make the function, and I will take all these things and let's make a function called sketch image, which will, for which we have to pass one argument and image. After that let's paste all of this one and it will return the mask, last one. As of now we can get rid of these things. Sorry guys. Now cv2 dot video capture, I'm writing 0 for because I'm going to use inbuilt web camera. If you are having external camera source connected to your computer, to your laptop, you can write 1 or 2 accordingly. Since I'm using the webcam, I'll write down 0. After that, while true. So we know that a video is nothing but a frame of an image. So if I have like thousands of picture captured at a particular frame, and if I run a series of that pictures, then I can see a motion that's nothing but video. So this is how we are recording the video. So now here we have defined the variable cap. So cap dot read, it's going to read our video, and after that we want to apply this function here. So let's call the sketch variable, and in that one now we don't have image, but now we are having frame, which is reading this capture, the video capture. So we can copy this one, we can paste it here also, and then we want to see. So by using imshow function, I can give a name, our live sketch, and I'll pass the variable sketch here. And instead of using wait key here, what I will do is I'll put if my wait key, and I'll put 1 here, is equal to odd q, then I want to break out of this loop. And if I am breaking out from this loop, then I want to release the capture. So cap dot, if I press tab, oh, if I press tab, I should get release. And after that I want to destroy all windows. So let's quickly run this one. Let's run all of the cell, guys. Okay, so there I am. I think I have to play a little bit. I have to change. That's my specs. Okay, yeah, it is having a good sketch. Okay, and for that I think we have to play a little bit with the values. So I press Q, and let's take lesser values, and let's try now. Okay, this looks a little bit good. You can see my hand. I'm having a little bit noise, but you can improve it. Thank you so much, guys, for watching this tutorial. If you like the video, please give a thumbs up button, and if you have any queries, then you can put it in comment box, and I'll try to reply as soon as possible. Thank you for watching this video. See you guys until next time. Okay, so that's it for the today. Thank you so much, guys, for watching this tutorial. If you like my tutorial, then please give a thumbs up button. If you have any queries, then you can put it in comment section below, and I'll try to reply as soon as possible. Also, in future we are going to try with some more filtering. Today I haven't covered the Sobel filter, then I haven't covered the Laplacian filter, but in upcoming series I'm going to add those also. And in my next video I'll try to explain the convolutional neural network for image classification. And see you guys next time. Please keep watching, and like, share and subscribe my video. Thank you so much, guys.